This is one of the exam problems in your packet, AP exam problems. And what I wanted to do with you right now is actually kind of go over it and provide you a solution. So what you want to do is you want to open your packet to the problem sets and find this problem. I forget exactly which number it is. It's like number 7 or 8 or something. And we're going to go through to the solution right now. First, let's draw a free body diagram of block. And so we're going to have, I'll make this just a little bit thicker. And wanted to actually make sure I have the right color. Let's get rid of that and try it again. So I want to have the normal force on the block due to the slab, and then we'll have the weight of the block due to the earth. This does not go in the free body diagram. That is the velocity. Now the block wants to move forward. There should be a force on the block due to friction caused by slab. And I'm trying to think if there's anything else we need. It looks like that's pretty much it. Now, let's look at the free body diagram for the slab and make sure we get this right. So we're going to have a normal on the slab due to earth. We will have the weight of the slab due to the earth. Now, notice there is a normal on the block due to the slab. By Newton's third law, there's going to be a normal on the slab due to the block. Okay, because the block actually weighs down on it. And there's a second third law pair. There is this force of friction right here, and there's a reaction force, a force of friction on the slab due to the block. Now, it looks like there's no friction between the horizontal slab and the surface, so we're good. So what we're going to do now is we're going to go ahead and we're going to say, well, at some moment before the block reaches the slab, both the block and the slab attain identical speeds. So we're going to do this by getting the acceleration of each block. So it says at some moment later. So all I did was I read the free body diagram. Now I can actually read the question. So I got a small block, slab. They give me masses. They give me a speed of velocity to the right, and we've got a coefficient of friction. And it says we want to find the speed at which we want to find. Apparently, at the same time, they reach the identical speed. So let's try to figure out what that is using kinematics. So the equation that describes the motion of the block is going to be V naught minus A of the block times T equals V of the block. Right? And for the slab, it's the friction that accelerates it, but we don't know how that happens. We have V of the slab equals A of the slab times T. So now let's do a little math here to figure out what is going on. So here we'll have V naught minus friction on the block divided by mass of the block times T equals VB. And for this one we'll have V of S equals friction slab block divided by mass of the slab times T. Now, how are we going to get the friction force? Well, we know the friction on the block due to the slab is going to be mu times NBS. So we can actually put that into our formula. And of course, you know NBS is mass of the block times G. So what we end up getting is, for the block, we're going to use V of the block equals V naught minus mass of the block times G times mu divided by mass of the block. So I'm actually going to write this just a little bit differently. When we actually work out all the math, we're going to get the sense of being V naught minus, we put this in for friction. We know that friction's mg, so we actually end up getting this curious mu times g times t for the block. And for the slab, we're going to actually end up getting v of the slab equals mass of the block times g times mu divided by mass of the slab times t. That'll be the two equations. Now, to get VF, these have to have the same speed at the same time, So what we can do is we can set V block equal to V slab and solve. So you're going to go do that. And then to get the distance the slab has traveled at the moment it reaches V of F, we're going to actually use x equals 1/2 a of the slab t squared plus v naught t plus x naught. At time equals 0, the slab's not moving and its position is 0. So then we're going to end up getting x is mu mb g over ms, put a little 2 on the bottom, times t squared. So that'll actually be the distance it travels. I think when you end up doing this, I think it ends up being something like I think the speed ends up being 0.57 meters per second, and I think the distance travels is like 0.49 meters if you do this right. Now, for those of you that are really creative, see if you can use work kinetic energy theorem to get the work done by friction. So if you can get the answer to D, then you're really good. So this is kind of a quick way of doing the problem. I'm going to actually have you take a look at this a little bit more in detail in class, but I kind of wanted to get you started on it and have you look at it tonight with a quick view.